Hi there and welcome back to the DevOL. I am Roman and this is the fifth episode of our F# introductory series. In the last episode we were talking about function composition. In this episode we are going to talk about lists, list functions, functions as parameters and Lambda functions. So it's a lot about functions and a lot about lists. The reason for this is that Klaras' business now runs pretty smoothly, but she has no real overview over her sales. We are going to change this by giving her a chance to assemble a list of all the scoops she was selling during a day and to calculate her complete day results. A lot to do, so los geht's! Alright, I said we're going to talk about lists. A list is a data structure in F# that is able to hold one specific type. Doesn't really matter which type, but it needs to be the same type for the whole list. So for example, we can build one list with the content 1, 2, 3, 4, 5. So evaluating this, we see that this is a list of integers, which holds the values 1, 2, 3, 4, and 5. The semicolon is the separator within lists. We can also use line breaks as separators. So we could use, in this case, 1, 2, 3, 4, 5. Evaluate this, and we see that in this case we have a list of floats. It's not possible to mix and match between those types in this data structure. So, for example, we cannot put an integer into our list of floats. Then we get the error that all elements of a list constructor expression must have the same type. Yeah, the error just said it. This is a list constructor expression. So with this expression, we are going to create a new list. Okay, this was a basic introduction into generating lists. What we are going to do is to create a list of all the sales of Klaras ice cream truck in one day. So for example, we have a new name called sales, and we put in there all the ice creams that she was selling all day long. And we see that sales is a list of strings in this case. Now we want to work with this list. What we're going to do is, first we somehow map each element of the list to a price, sum all the elements. This is what we are going to do. First of all, we map over each element within the list and try to calculate the price of this element. And after we've done this, we can sum all the elements and therefore enable Clara to know how much money she got or she earned during her day. Alright, let's start with the mapping. The F# list module, which is always open or always available when you're working with F#, provides us with a function called map. And we call it like this. But first, before we use it, we need to see the type of the function, to see what we can do with this function actually. Right, so the type of this function is list.map is defined like this. I will explain this in a second. Okay, so this function needs two parameters and it returns a third parameter. So the second parameter of this function is a list, and this here is a type parameter, which means in this we can fill this type parameter or type variable with any specific type that we defined or that F# already has available for us. So for example, we could say we input a list of ints and we will get back a list of ints. But as you see here, the U and the T are not the same. So we do not need to get back a list of the same type. For example, it's possible that we put in here a list of strings and we get back a list of floats. What does this mean? The first parameter of this function is another function. This is a very important concept in F# because in F# or in any functional programming language, functions are first-class citizens, which means there are also values that can be used as parameters into different functions or into other functions. Again, this is very important. Functions can be defined and can then be used as parameters for other functions. So this map function here, list map, takes a function and takes a list of something as parameters and returns a list of something else. And this function, the first function, is the actual mapper function, which means it takes, in our case, a string and returns a float. All right, let's implement this. So we have our list of strings, and what we want to do is that we want to take each entry of the list and put it into the price for special function so that we get the price for this special out for each element of the list. So what we want to have later on is not a list of strings anymore, but a list of prices for each and every entry into this sales list. Okay, let's do this. We say sales and we pipe this into the list.map function, and then we introduce a new concept, which is an anonymous function or a lambda function. A lambda function is a normal function that has no name defined. So when we look, for example, at this function, the price for special function, doesn't matter. Each of the functions is possible. It's just a normal function that is doing something, but it is bound to a name or to an identifier. A lambda function is not bound to an identifier. It's defined inline at the place of usage. So for doing this, we need the braces, and then we use the fun keyword and get the flavor as the parameter into our function. And the return value of this anonymous defined function, lambda function, is the price for special of our flavor. So when we run this, we see that we get back a list of 1.1 euro, 1.1 euro, 0.9 euro, etc., etc. So we mapped each special to its IS4 and then to the price by using the price for special function, which we defined in the last episode, and we used this to map over our list. After this, we can use another function which is defined in the list module, which is called sum. And when we evaluate this, we see that this function just takes each input of a list and sums all of them together. To recapitulate, we use our sales list of strings of flavors, put this as the second parameter into our list map function, where the first parameter is our mapping function. When we, as we see here, our mapping function takes one parameter, which is a string, as an input and returns a float. So the whole list map function returns a list of floats. Our price for special function takes one string as an input. This anonymous function also takes one string as an input, so we don't need to define a lambda function all the time. We could, in this case, also use just the price for special function. It's even more readable now. We say we map our sales through the price for special function and sum it. What is important to notice is that lists are, like everything in F#, immutable. So by doing this, we are not changing this list here. We are creating a new list with all the values mapped. So we can check this again. We call this stuff we get a new, in this case even we get a float out of it, but if we call this, we get a new list out of it. But if we just run the sales, evaluate the sales in the REPL, we see that it's still the old list with the old strings in it. So let's imagine Clara wants to play a bit with the prices. She thinks maybe it's even possible to take more money for my special branded ice creams. How can she play around with this? Well, the list module gives us different functions that allows us, for example, to filter a list to only use part of the list for our later usages. So, for example, the list module offers us a function which is called filter, which enables us to only work with a specific subset of our list. So, for example, we could say list.filter, and this filter function takes also a function as the first parameter, but this function needs to return a boolean. Okay, so let's do this. We say function flavor returns flavor equals strawberry. No, we don't have strawberry, we only have red rising. Can evaluate this, and we see we get back a list that only consists of red rising ice creams. Then we could say, okay, we want to map this to price for special. Now we know how much money the red rising gave us when we actually listed sum this. So only the red rising gave us €3.30. But now Clara thinks, what would happen if I took maybe 20 cents more for each of the ice creams, or for each of the flavors or scoops here in the red risings? And I really don't want to change all my stuff up here. I just want to play around a bit with it. Well, we could use another mapper and say list.map function. Now we get a float in here because we already mapped this to a float, each element. We could say x plus 0.2. Again, we have our sales. We pipe this to the filter. We pipe this to the filter, so we only get red risings. We pipe this to the price for specials, which is always 1.1. Then we pipe this result through the next anonymous mapper, and now each of our entries is 1.3. And then we can sum it all together, and we see that it's 3.9. And we copy this and leave this out. We could see that in here we have 3.3, and when we raise the price, of course we get more money, we get 3.9. Another very helpful function of the list module is the length function. So for example, if we want to know how many scoops of a specific flavor we sold, for example here we use Cream Dream, and we just want to know how many of this flavor are in my sales list, I could just say length, run this, and get back to, just to make sure that it's right, Cream Dream and Cream Dream 1 and 2. Awesome. So we introduced a new way for Clara to keep track of all her sales during a day and to calculate the results of one day. We even gave her the possibility to check how many flavors of a specific type she sold and how much money she get just out of one flavor or the other flavor, or what would happen if she raises the prices for one flavor a bit more even. But what we have is one big problem. The only thing we used to identify our flavors in our whole calculations here were strings. So everywhere we had to enter the whole string red rising, cream dream, vanilla, strawberry, if we wanted to work with those flavors. The problem is now, first of all, we don't get any autocompletion or IntelliSense from our editor. So when I write cream dream, my editor doesn't know what kind of string I'm going to enter here, so it can't help me. And the much bigger problem is that I can make mistakes that lead to completely strange results that I really can't understand. So when, for example, we evaluate this here again, we get back 5.1. Now I want to, Clara want to add another flavor, another salt ice cream scoop, and I make a mistake in here. So what I do expect in here is not 5.1 euro, but 6.2 euro. But when I evaluate this actually in here, what I get back is 6 euro. And the reason is that I made a mistake in here. And in here we say if ice equals red rising, then we get back strawberry, otherwise vanilla. Because it does not equal red rising, because I wrote it without a space. It says else we use the vanilla case, which is in the end only 90 cents. And this would make a lot of problems, of course, many bugs. And in order to be able to solve this, in the next episodes we introduce one of the nicest and coolest features of F#, which is discriminated unions in conjunction with pattern matching. I really hope to see you there. Bye bye.